Julian? Can you hear me? You got that squeaky voice again. Let's see. What did we do? Can you log off and log back on? Hi, what are you barking at? I don't understand exactly what it's doing. But it always seems to get cured when you log off and log back. You can hear me fine when that happens, I presume?
Yeah, I can hear you fine.
Huh, weird. All right, piecewise functions. This looks like Algebra 2.
Yeah, he said that we're like done with all the geometry stuff for the semester, so we're just going to get started in Algebra 2.
Cool. Cool. Okay. You probably dealt with piecewise functions in Algebra 1 a little bit, didn't you?
A little, I think.
Mm-hmm. All right. What I usually tell everybody is begin everything from the right side and work left to right.
Okay.
Okay. So, I've done these two ways in my life. I'm going to show you both.
Okay.
Then recommend that we do it the second way. But it doesn't hurt to do it the original way I used to do it, just because it kind of shows you what's going on. So there's our key point, 2. When x is less than 2, in other words, everything to the left and equal to 2, we have the line f of x equals minus x. Well, how would that plot? What's the y-intercept?
Is it 2?
No, let's look at it. Well, let's just look at the line for a moment. We know how to graph that, right? B is the y-intercept, m is the slope.
Yeah.
Okay, so this is y equal minus x. So what's the y-intercept?
Minus x.
No, compare it to mx plus b format. B is the y-intercept.
Yeah.
B is 0 here.
Oh, okay.
Okay, so there's one point that we know is on the curve. What's the slope?
-1.
Minus 1. That slope, minus 1, looks like this.
Okay.
So that's the way I might start. However, what I would do is stop it when I got to 2. Right there.
Okay.
With a closed dot. So I've graphed minus x everywhere to the left of 2. To the right of 2, my function is y equal x. Well, where is that y-intercept?
It's just 1, right?
0 again.
Oh, yeah, 0.
What's the slope?
Just 1.
Okay, so normally this line, let me choose a different color. Let me erase this. Normally this line would look like this. Right? me to the right of that point right there. So I really want to erase all of that and put just this point like that, and it's open because when x is equal to 2, we're on the red line. It's only when x is greater than 2 that we're on the blue line. So this would be an open dot like that.
Okay.
Now, that's kind of the hard way to do it, where you draw the full line and then you cut it off at the point you're supposed to. Okay? I quickly realized that there's a much better way to do this. You don't have to take the blue line all the way to the origin. In other words, to do the blue line, I'm looking at the equation y equal x. Well, to figure out where I'm going to start up here, plug in 2 for x. Even though this line doesn't exist at 2, that's a good place to start. Okay, so if I plug in 2 for x, then my starting spot is right there. In other words, since y equals x, if x is 2, y is 2. So I don't have to worry about a y-intercept. Because all I have to know is where my first point's going to be. And now I know the slope is 1. So I know it has, up 1 and over 1, so it's going to look like that. In other words, I can start my graphing at the point that I need to start at. I don't have to draw this line all the way to the origin and then erase this part of it. You understand?
Kind of.
Okay, well, let's have you do the next one.
Okay.
Let's take a look at it. This one's pretty easy. Let's lay down our grid. When I say have you do it, I mean have you tell me how to do it. So there's our key point, 3. Notice that we only have 2 possibilities. X is either greater than -3, which is everything in this direction, or x is less than -3, which is everything in that direction.
Okay.
You've almost got it correct here. It's 2, but it's 2. In other words, starting with this one, working left to right, where am I going to start my open point? Well, right there. If this is 2, here, let me label that 2.
Okay.
My first point has to be right there.
Okay.
And then the horizontal line continues all the way. And she has you put arrows on them or not?
I don't know. I just did. I don't know.
I don't think you need to.
Yeah.
It's not wrong because the line does extend to infinity in that direction.
Yeah.
And it's almost helpful to view it. Okay, so now let's go down and look at the second part of the piecemeal. It is -5, but you got it starting from the y-axis. In other words, you had everything coming from x equals 0, as if this -3 was a 0. If this -3 was a 0, you've graphed it good. Although this is not a vertical line right here.
Yeah.
Take that vertical line out. And since it's -3 instead of 0, well, the other line starts at -5 and goes to the left. And both of these, and I'll bet this is a typo, both of them are open dots, which you almost never see because it's not continuous. There's no value at -3. The function is not defined at -3, at x equal -3. usually one of these would have a equal sign on it, so that the function would be defined at all points. All right, so let's go to the third one here. All right, you should be able to tell me how to do this. I'm going to leave my grid there. First thing I got to determine is what's my key point on the x-axis?
-2.
Okay. So let's work starting from the left.
Okay.
Whenever x is less than or equal to -2, so I'm going to start with a closed dot.
Okay.
How do I proceed?
So you should start at the point -1.
On the x or the y axis?
On the x.
No, on the y axis.
On the y?
Yeah. In other words, it's saying that f of x is y.
Okay.
Okay? So it's saying that y is equal to -1. Well, if -1 is right there, then that means I have a closed dot, and there's my top part of the piecemeal function, piecewise function.
Okay.
Now, going to the right, I'm going to start right here with an open or a closed dot.
With a open?
Okay, and we're at 2, so actually that looks like 2 based on my scale. So actually I'm going to start right there.
All
Which
right.
way does my line go?
To the right.
And there's my function. And notice that at -2 it is defined. It's equal to -1. In other words, f of x is equal to -1 at x equal -2.
Okay.
Okay, this one has 3 pieces. What are my key points?
They are 1.
When I say that, I mean, what are my key points on the x-axis?
Okay.
Starting from the left.
So, they were -1.
Okay, we'll make that -1 right there. What's the next one?
+1.
Okay. So, I'm going to start where? With my first point, is it going to be a closed dot, an open dot, and which way am I going to go?
Alright, it's going to be a closed dot to the left.
At a y value of -1.
At a y value of -1.
Okay, so I'll make that -1, and it's a horizontal or vertical line?
It is horizontal.
All right, so that's the left part. Now, between -1 and 1, what should I do? Open dot, closed dot, and where on the y-axis do I start?
You should put a, is it open dot?
Starting where?
Starting at 0.
Yeah, in fact, give me the starting xy coordinate. That's the best way for you to describe it.
So,
What xy coordinate would I start at?
would it be 0, -1?
No, it would be -1, 1. In other words,
negative
there's
1,
-1, 1 right there.
Oh, okay.
Right? In other words, I know I'm starting at -1 and going to go to 1, but where do I start on the y-axis? Well, it says y is 1 in this interval.
Okay.
So I would have this open dot like that at 1. And now let's go to the right of that. So to the right of that, where am I going to start? Which xy, in other words, for you to describe where I'm going to start, give me the xy coordinate. This is a y value of 1. This is an x value of 1. So where am I going to start for this third piece?
You start at 1.
What's both coordinates?
Is it just 1, 1?
Yes. In other words, I start right there. Why? Because I'm going to, even though this thing says x is greater than 1, I'm going to use it as a reference point as to where I start. So I'm starting my line. It's going to be an open circle right there on top of the other open circle. And what's this line look like? Is it horizontal? Is it vertical? Or is it sloped?
It's
Y equal x.
Is it horizontal?
No, it's as you've drawn it here. Slope.
Oh, is it slope?
Yeah, it's got a slope of 1. 45-degree angle. Meaning I go up 1, over 1, up 1, over 1. Always remember that when you see y equal x, there's a hidden 1 in front of that x. And remember, the general format is y equal mx plus b. You need a little review on that because you've been taking geometry all year. You haven't really dealt with that too much.
Yeah.
So I'll keep reminding you of that. So when you see y equal x, you know the slope m is 1 and b is 0.
Yeah.
But we don't care what b is here because we're not starting on the y-axis, this part of the curve. We're starting it at 1, 1. So I'm not taking it all the way back to b. If I extended this line all the way, it would go through 0, 0. But it's not defined there. It's only defined when x is greater than 1. So you would have it like this. And there's certainly nothing wrong with putting arrows on that. I don't know if your teacher wants you to do that or not. You might find out before you take a test.
Okay.
Now, there's a vertical arrow here that doesn't belong.
All right.
Okay. It looks like you've got the left one, and it needs to start at -1. You can see how I've done it here. So I would suggest that you erase what you have on here while we're going through it and draw it like I'm showing here.
Okay.
Because you got a lot of lines on here that shouldn't be there. All right. Now, they get harder as we go along. Notice that they're no longer nice just numbers. The first 3 we did were all just numbers, which are horizontal lines.
Yeah.
But starting with 5, so if y equals mx plus b, key number here on the x-axis.
Is it?
Always look over here when you start analyzing these things. Don't start with the complicated function. Start where we're going to draw our dividing line on the x-axis.
So 0?
So there's our key point. We've got one function to the left, and notice both of these functions are straight lines with slope.
Yeah.
Both of them.
Okay.
So we're going to have, to the left, we're going to graph y equals minus x plus 2. So where should I begin?
So you should begin at...
Give me the x and y coordinates.
Is it 2, -1?
It's 0, 2. In other words, this 2 up here tells us that this line is going to intercept the y-axis right there.
Okay.
Okay. It's greater than or 0, so it's a closed dot.
Yeah.
And what's the slope of this line going to be?
The slope is -1.
Okay, that looks like that. It's a 45-degree line. And there you have your line to the left of the y-axis. Okay, now let's go down and see what we got to the right of the y-axis. Well, to the right of the y-axis, our y is going to be this. Where does that begin? What xy coordinate?
0, wait.
Yep.
3, 0?
No, you had it right. The x coordinate comes first.
Okay. 0, 3?
Yeah. If this is 2, this is 3, is it a closed dot or an open dot?
It is a open.
What's the slope of this line?
1/2.
How do I do that?
Up 1/2.
Okay, so that if I go up 1 and over 2, that looks like a slope of about 1/2. A little flatter than 1. I've drawn it actually not very accurately relative to this one over here. Let me redraw it. But it's not quite that flat. There, that probably looks more like it. And again, this function is defined everywhere, including right there.
Okay.
All right. And I'm not going to worry. This one looks like you did it correctly, almost. No, you got it. Yeah, you got the wrong slope on the one line. So let's look at this. Where's the key point on the x-axis?
The key point is 2.
Okay. I'm going to start on the key point, but I know the first thing I'm going to graph is going to go to the left.
Alright.
Where's my starting point?
2, 2.
When x is 2, what is y? Remember, we're doing the top one.
Okay, equal to?
No. When x is 2, what is x plus 2 equal to?
Oh, so is it 4?
Okay, so where's my starting point?
2, wait, 4, 2?
The first one is the x coordinate, the second one's the y coordinate.
So 2, 4?
Yes.
Okay.
So 4 is up here. Closed dot or open dot?
Closed.
What's the slope on my line?
Is it, is it just 1?
Yep. And I also know, because this is going to cross the y-axis, I know it's going to cross at 2, so I know it's going to go through that point. And draw it. So there's everything to the left of 2.
Okay.
To the right of 2, where am I going to start? And this point right here is 4. So how do I figure out where I'm going to start? What's the x-coordinate of where I'm going to start?
It's 1/2 plus 4.
That's the y-coordinate. What's the x-coordinate of where I'm going to start?
Is it just 2?
Yes. What's the y-coordinate?
1/2, -1/2 minus 4. I mean plus 4.
Plug in 2 for x and give me what this number is.
Okay,
This is
so
y. Remember, this is
Do you
y.
multiply it then?
Yeah, if we're going to start at x equal 2, then plug in 2 for x. You get minus 1/2 times 2, which is minus 1, plus 4, which is 3. So my y coordinate is 3. Open or closed?
It's open.
What's my slope?
Slope is it negative?
Negative what?
2?
Negative 1/2. Negative 1.
Oh, negative
Just the
1/2.
coefficient of x.
Okay.
And negative 1/2 looks like that. Now, when I look at your drawing, it looks like you did it the way I used to do it. In fact, you've done it exactly that way. In other words, you plotted this line by starting with a y-intercept of 4,
Yeah.
and then you went like that. And that's okay, but then you got to go back and erase this part of it. Because you notice this part is not part of the graph.
Yeah.
Because that only starts at x equal 2 going in that direction. So you don't really notice how much easier it was to do it the new way, the second way, where we figure out our starting point by plugging x equal 2 into the function, and that's where our open circle goes, at 2, 3.
Okay.
Okay? And I realize you're only going a half hour tonight, so we'll try to do one more here. I think you're getting it, aren't you?
Yeah, this isn't too hard.
No, it isn't. Really, once you do a few of them, where's my starting point?
We're on 7. Negative 2.
Okay. I think if we do this last one, you'll be able to do the rest on your own.
Yeah.
So, now what? Where's my starting point?
So we're going to start at...
Give me the x and the y coordinate.
Negative 2, negative 3.
Plug in negative 2 for x.
Oh, yeah.
Now solve that.
Negative 6.
That becomes a positive 6.
Oh, alright, so...
Because when I plug in negative 2 for x, I got negative 3 times negative 2. That's positive 6.
Are they both negative? Is it negative 2, negative 2?
No, this becomes positive 2.
Okay, so negative 2
Let's just go through that algebra, because you get hung up on the algebra. So when I plug in negative 2 for x, I now have, well, what is that? That's positive 6.
Yeah. Minus 4 is positive 2.
Okay, so that's how you solve for y. And so our first point, closed dot or open dot?
It is a closed.
Okay, right there. That's negative 2, 2.
Okay.
And then what? Now, in other words, now we have to go to the left.
Yeah.
Well, how do I go to the left? Slope is all we need to know. What's the slope?
The slope is negative 2.
It's the coefficient of x. Remember, y equals mx plus b. That's slope.
Yeah.
Always. In this case, that's minus 3.
Okay.
So I need to draw a slope of minus 3. Looks something like that.
Okay.
To the right of minus 2 on the x-axis, where am I going to begin? What coordinate?
You'll begin at, is it just positive 1?
I'll start with the x-coordinate.
So negative 2, positive 1.
Well, plug in negative 2 for x and solve that.
Okay. So is it just negative 2 plus 1?
What does that equal to?
Negative 1.
Okay. That's my y coordinate.
Okay.
For my starting spot. Negative 2, negative 1, open or closed?
Open.
There's my starting spot. Negative 2, negative 1, open circle. What's my slope?
The slope is 1.
Plus 1. So
Plus 1.
that's a 45-degree line. That's how you do it.
All right.
That's how you do every one.
Okay.
The biggest difficulty you're having is substituting your key point in for x and then solving that. And you want to review that. In other words, you want to make sure you do that part. That's more important than the piecewise function. You got to be able to solve a simple equation. In other words, what we're really doing here, this is a good case where we're using f of x. If f of x equals minus 3x minus 4, what we're really figuring out is what is f of minus 2. In other words, we're going to plug in minus 2 wherever we see x and calculate the result.
Okay.
That's what you need a little practice on. So make sure you finish the rest of these and you solve each of these by plugging in minus 2. You don't have to clearly when it's minus 1 because it's minus 1 regardless. There's no x to plug in. But when it's minus x minus 4, you need to plug in minus 2 for x.
Okay.
And then solve. All right. I will let you go.
All right.
Okay.
Cool.
And have a good one. I'll talk to you next time.
All right. Thank you.
Bye-bye.
Bye.